Okay. When we study derivative, we said when we take the derivative of a position function s of t, we can get the velocity function. And if we take the derivative of the velocity function, we can get the acceleration function. So, according to the definition of antiderivative, since the derivative of s of t is vt, therefore s of t, the function s of t, is an antiderivative of vt. And since the derivative of vt is at, then the function vt is an antiderivative of at. So if we are given the acceleration function, to find the velocity function, we can find it by using the integral, okay, by finding what is the antiderivative of this function at, and that function will be the velocity function. And similarly, if we want to find the position function, then we take the integral of the velocity function, which means we need to find what is the antiderivative of the velocity function. So that will give us the position function. Okay, now let's take a look at this example. A ball is thrown into the air from a height of 1 meter with an initial velocity of 15 meters per second. What is the velocity of the ball after 1 second? When does the ball reach its highest height? And what is this height? We assume the acceleration is due solely to gravity, which is a negative 9.8 meter per second square. So in this problem, so a ball is thrown into the air. And what we know is the initial velocity is 15 meters per second. And the acceleration is a constant. The acceleration is negative 9.8 meters second square. Now, this negative sign here is because we assume the positive direction is upward, and since the direction of the movement is downward, so that's why it's negative. Okay, and we want to find the velocity of this ball after 1 second. So in order to find this, we need to know what is the velocity function. If we can have the velocity function, we can just plug 1 into the function, then we can have the velocity after 1 second. So the first thing we are going to do is to determine what this function is. Okay, we said since the velocity function vt is an antiderivative of the acceleration function at, so to find vt equals the integral of at dt. Now here, remember, since our function we use t as the variable, so in this integral, in this symbol, we have a of t and dt, not dx. Okay, and this equals the integral of negative 9.8 dt. So the antiderivative of this okay. Now after I bring the negative 9.8 outside this integral sign, so we use that trick again. So 1 we write as t to the power of 0, and then use the power rule. We can find the antiderivative, which is a negative 9.8 t and plus a constant c. Okay, now then, in order to determine what this function is, we need to determine what is this constant. Since we are given the initial velocity, so the initial velocity is the velocity when t equals 0, when the time is 0. So v of 0 equals negative 9.8 times 0 plus this constant, and this equals 15. Therefore, this constant c is 15. So now we have find the velocity function. Okay. Now, then use this velocity function, we can answer the first question. After 1 second, the velocity is v of 1, which is a negative 9.8 times 1 plus 15. So that is 4.2. Right. Sorry, it's 5.2. Okay. Now the second question is when does the ball reach its highest height? So when the ball reaches its highest height, what happened to the velocity is the velocity of the ball will be 0. Because if the velocity of the ball is not 0, this ball will continue to move upward. So at this point, at this highest point, what will happen is the velocity is 0. Okay, so to know when will this happen, when does the ball reach its highest height, we need to solve this equation for t. So we solve this equation negative 9.8t plus 15 equals 0. So t equals 15 over 9.8. So it's around 1.53 seconds. Okay. So after about 1.53 seconds, this ball will reach its highest height. And then to determine what is this height, we need to know the position function first. Because once we have the position function, then we plug this number 1.53 into this function. It will tell us what is the position. In other words, what is the height at this time. Okay, and to find the position function is the antiderivative of the velocity function. So we take this symbol, this integral of the velocity function. dt. Okay. So then this will be the integral of negative 9.8 t dt plus the integral of 15 dt. And then we write this constant outside the integral, and we write this constant 15 outside the integral. Then use the power rule. So have a negative 9.8 t squared over 2 plus 15 times t plus another constant c1. This time to determine c1, we need to use the initial condition for the position. Let's go back to the problem to see what else we haven't used yet. Okay. Now in the first sentence, it says the ball is thrown into the air from a height of 1 meter. So this tells us when t equals 0, the initial position of this ball, at this point, the initial position of this ball is 1. So s of 0 equals 1. Since s of 0 equals 1, so negative 9.82 times 0 squared plus 15 0 plus c1, this equals 1. So this constant equals 1. Right. So the position function is negative 9.8 over 2t squared plus 15t 1. Okay, and when t equals 1.53, so this will be plus 15t plus 1. So when t equals 1.53, the result is about 12.48. So probably so around here, 12.48. Okay. All right. So this is how to use the antiderivative to find the velocity function and the position function when we are given the acceleration function, and with some initial conditions. So here the initial conditions we're given is the initial velocity and the initial position.